My cough is getting much better. I've practiced a lot. So, no, I'm on some kind of like powder steroids that you inhale. It's weird, but it's getting better. See, last week we did parabolas and ellipses, right? We're in our conics section. So let's look what we're going to finish up. And we talked about circles. We didn't really demonstrate circles because circles are old hat. We were more familiar with circles than we were the other stuff. So, but this is our last conic that we're studying today. So we'll look at this. Let's go down to 0B, Algebra 3. Let's go to our grade screen as usual. All right. Well, haven't graded. I've got a lot of grading to do, guys. If you've turned something in, it's not graded. That's me. I've got lots of stuff. I was out Friday in Little Rock, and that has piled up a lot of things to be graded. But I'll get caught up as soon as I can. I will be updating the grade book today before advisory, but it won't have all the stuff graded that's been turned in. It'll just be updated with everything that's already graded in Buzz, and we'll go from there. But I'll get it done. Hopefully, well, I will have it done by Thursday. Thursday is parent-teacher conferences, so I'll have all the grading done by Thursday. Because yeah, parent-teacher conferences. Love to visit with any of your parents who'd like to come by. If you'd like to join them, you're welcome to. But yeah, we should have everything turned in from parabolas and ellipses, and everything from Module 5 should be in. So if there's anything you're missing, go get that turned in, and I'll get it graded by Thursday and get it updated in the grade book. But today, let's see, this is this week's 6.03a and 6.03b, hyperbolas and a Conic Collage. Oh, we get to do a collage this week like we get a little kid. You cut out the magazine pictures. We did that in grade school. We enjoyed that. We're going to have a little flashback to that this week. Let's look at 6.03, parts A and B. All right, as you can recall, like in an ellipse, we defined an ellipse as the set of all points that the sum of the distances from the two focus points was constant. Remember, we had showed the distance from the one focus point and the other focus point, and we added those distances together, and it was always the same. No matter where we moved around the ellipse, that distance was always the same. Well, for a hyperbola, it's the difference of those distances. It's the difference. Instead of the sum, we're subtracting those differences. And I have a little graphic that shows that right here. So here's a hyperbola. It's like two parabolas back to back, kind of. Not exactly a parabola. It's not exactly the shape that a parabola is, but it's very similar. So two back to back. And you can see we have two focus points, just like with an ellipse. There's one over here, one over here. They're inside those two curves, those two shapes, right? The two parabola type shapes. The focus points are inside, just like they're with the parabola. But there's two of them, since there's two of these. Let me make this a little bigger. And it still has two vertices, just like an ellipse. Now notice these are horizontal. There's two types of hyperbolas. You could have a horizontal one, or you could have a vertical transverse axis. But here's what's kind of cool about this. This is a little bit more cool than just adding them together and being the same. No matter where we move this point P, the distance between those two, the green line and the red line, if you subtract that, the distance is going to be equal to this transverse axis. You're like, what? Yeah, let's see that. Watch this. If I slide this, let's take that transverse axis and put it up here even with the green line. Find me. And then here's taking the green line and putting it up there on the transverse axis. And then the red line, if we put it over here on this part of the transverse axis, and look, see the transverse axis is the difference between the two. That is the difference between the two distances. So any point on the line, we can do that. So let's move our point and see that. Let's move our point way up here. So now the green line's gotten much longer and the red line's gotten much longer. But still, if we slide this up and bring the green line, line it up with the transverse axis, and put the red line over here, it is the transverse axis and the shorter distance added together equals the longer distance. Pretty cool. Let's bring it down close. This, we can see it right there. Let's slide this up and look. Bring the transverse axis up. Bring the green right there. Put the red right there. It's still the same distance. So that's kind of cool. At any point on the line. And we can move, let's see, well, let me move the point over here. Well, it works the same on both sides because it's a mirror image. So it doesn't really matter. Well, I can't move the P now. I've got the P stuck. That's all right. The point is there. But that's what we're looking at. So definition of a hyperbola. It's the set of all points that the difference of whose distances from two distinct fixed points, the foci, is constant. It's that same distance, the difference between there. And in this case, the difference was the length of the transverse axis. Every time. That was when we subtracted the green one, subtract the red one from the green one, it equaled the blue one every time. So it's the distance of that transverse axis. And that stays constant. That doesn't change. So each hyperbola has two branches. You see the pictures over here that are not connected. The vertices are intersected by a line drawn through the two focus points, the two foci. That's where the vertices come from. They're all in a straight line. So the line segment that connects the two is called the transverse axis that we saw on our graphic. And of course, we also have a center. The midpoint of the transverse axis is the center of our hyperbola, right in the middle. And there's also horizontal and vertical. It could be either one. If we just turn this 90 degrees, that's what it would look like. And let's look at the equation, standard equation. So the standard equation is x minus h squared over a squared minus y minus k squared over b squared equals 1. And you're like, wait a minute, wasn't that the equation for an ellipse? Why is the equation for a hyperbola the same as an equation for ellipse? Well, it's not. It looks very, very similar. If you pull out your notes from last week, you'll see we did have x minus h squared over a squared and y minus k squared over b squared equals 1. But the big difference is with a hyperbola, this is a minus. This is a minus. It was a plus for the ellipse. Exact same equation, except a plus. So hyperbola is a minus. Now, with an ellipse last week, when this was a plus, if we made it vertical, all we did is we switched the a squared and the b squared. We made a squared was always the bigger number, and we just moved it over here. But since this is a minus, we do something a little differently. We move these two for a vertical. The bottom stays the same, a squared and b squared. We switch the top of the fraction. We move the y minus k and the x minus h. Those trade places for a vertical. But it's still a squared, b squared equals 1. Still a minus. But that's the only difference in the equations. All right, let's go back and look at this. So the transverse axis horizontal, transverse axis vertical. Now, of course, if the origin, the center is on the origin, h and k are 0, then you get the very simplified version. X squared over a squared minus y squared over b squared equals 1. So that's when the origin is where the center of your hyperbola is located. H and k are 0. Makes that real easy. All right, so let's do a test your skills problem right here. Find the standard form of the equation, which is shown right up here, of the hyperbola that has foci at -2, 4, and 8, 4, and vertices at 0, 4, and 6, 4. So let's write that down. That's the focal points. That's the two vertices. We need to find, if we're going to write the equation for this, we need to find h and k and a and b. So center, hk, and then we need to know what a is. Oh, not a, I wrote a twice. And b is. So we need to know a and b. We need to know the center a and b to be able to write that equation. Now, one thing that we have Just like with the other, we do have the C. C is the distance from, and this is just like an ellipse. C is from the distance from the focus to the center. A is just like it was with an ellipse. Distance from vertex to center. B is a little different. B was the height of the ellipse. We don't have an ellipse that's closed. We have a hyperbola that goes on to eternity, right? Infinity goes on forever. So our B is a little different, but there is an illustration I can show you that talks about some of this. Let's look at this. So B, this has a B of 4. A of 3. A is 3 right here. See, there's the center and there's a vertex. So it's a distance of 3, and that's our A. And we can change that. We can make it a wider vertex. B is actually a calculated number. B is 4. Notice the distance from the center to the focal point is 1, 2, 3, 4, 5. That's a distance of 5. So we don't have that automatic height to play with, except for it's a calculated thing. And let me show you how to calculate that. This one actually works just like the Pythagorean theorem. A squared plus B squared equals C squared. The ellipse was different. Remember, it was a minus. So to figure out B, we have this formula. All right, so let's see what we can figure out from here. What is our center? Let's put it on Desmos and take a look at these points, because that's a nice, easy way to do that. But granted, it'll bring a nice one for us. We had 2 focal points at -2, 4, and 8, 4. All right, let's label those. All right, so there's the 2 focal points. There's 2 vertices. We have at 0, 4 and 6, 4. Let's label those. Okay, so we know that the center is exactly in the middle between the vertices, or exactly in the middle between the focal points. The center is the center, regardless of how you look at it. So let's look at it between, let's turn off the focal points and the labels, and just look at the 2 vertices. Here's the 2 vertices. What's the center point between them? Well, if we see the total distance is 1, 2, 3, 4, 5, 6, the center point has to be the point 3, 4. That's the center right there. So we can put our focal points back on there. It's also the center between the focal points. 3, 4. So let's write that in our notes here, because that's part of our stuff we need to write this equation. So 3, 4 is our center. Great. A. What was A? A was the distance from the vertex to the center. Oh, well, we just looked at that. Here's the vertex. Here's the center. Distance of 1, 2, 3. So A equals 3. All we need is B, and we can give our answer. And we also have to know, is this horizontal or vertical? Well, everything is lined up horizontally, right? The vertices are horizontal. So we're writing this equation up here. It's a horizontal. B, we have to calculate B. So we need C. That's the distance from the focus to the center. So how far away is the focal point? Well, we can go from 3, 4 to 8, 4, or 3, 4 to -2, 4. It doesn't matter. Let's do 3 to 8. That's the easiest. That's a distance of 5. 1, 2, 3, 4, 5. 8 minus 3 is 5. So we know that C equals 5. So let's calculate what B is then. So we can use this formula and fill in what we know. We know 3 squared plus b squared equals 5 squared. 3 plus the b. There we go. All right, so this is 9 plus b squared equals 25. Subtract the 9, b squared equals 16. So b equals 4. Because b squared equals 16. The square root of b squared and the bare square root of 16, b equals 4. We have everything we need now to write our equation. So x minus h, which is 3, squared over a squared, 9, minus y minus k. K is 4, squared over b squared. Well, b squared's right there. Equals 1. There is the equation for the hyperbola that has focus points here and vertices there. That is the equation. Let's check our work to see if we got what they got, because it has check your answers right there. It should show you some of the steps to get there. The midpoint tells you the center. We know C is 5, A is 3. So it calculates B squared to be 16. X minus 3 squared over 9. Y minus 4 squared over 16. Subtract equals 1. All right, that's what we got. All right, here's the other thing I want to talk about. Asymptotes. A hyperbola has 2 asymptotes, and they intersect at the center. Now, this is the asymptotes pass through the vertices of a rectangle that has the dimensions 2a by 2b with the center at hk. All right, let's look at that. I do have this illustration. All right, let's see if we can't. Let's see, I'm going to reload that because it's not letting me maximize that. All right. Let's see if we can set up the exact same. Oh, this is the same one we had, except the h and k is different. So let's set it up to be exactly the same. Let's make the h equal to 3 and the k equal to 4. The b is 4 and the a was 3. There's the a. All right, so this is exactly the same hyperbola we just worked that problem for. Has the center at 3, 4, negative 2, 4, and 8, 4 are the focus points. The vertices are at 0, 4, and 6, 4. Now it says the asymptotes. It shows the asymptotes right there in the purple dashed lines there, the dotted lines. Notice as, oh, this won't let me zoom out. I can't zoom out on this illustration. If we zoom out, and we're going to write the equations for these asymptotes, and we'll be able to do it on Desmos and zoom out. The hyperbola gets closer and closer and closer to those asymptotes, but it never touches it because that's what an asymptote is. It's a line that a function approaches but never crosses, never touches. So what's that rectangle let's talk about? Well, if you take a rectangle as 2a by 2b, you can kind of see it in black right there. As the rectangle goes down to the x-axis, across here, up, and where the red line is there. There's a rectangle right there, and the asymptotes cross through the corners of that rectangle. Through the corners of that rectangle right there. Pretty cool. That kind of tells you where the asymptotes are. So if you knew A and B, you could draw that rectangle, and you could draw the asymptotes without knowing the equation, because you know it goes through the corners of that rectangle. But we do have the ability, put that down, to write the equations for it, because here's the secret. All right, we're going to put this on our notes. I wrote that in my notes up here at the top. Because, remember, you can use your notes on anything, quizzes, tests, assignments, everything. So it's great to have all of this up here in your notes. Because otherwise you have to close the test if you want to go back to the lesson and figure out what those equations are. You don't want to keep having to close the test and go back and look and then go back and forth. And, have this in your notes. Make this easy on yourself. All right. So here's the asymptotes for a horizontal. So let's write the asymptotes here. Y equals, this is y equals k. Well, our k was 4. And it says plus or minus b over a. B over a. 4/3 x minus h. X minus 3. So you said, but there's 2 asymptotes. Yes, this is 2 asymptotes. Notice right here, we've got plus or minus, just like with using the quadratic formula. You got a plus or minus in there. That means one of the asymptotes is y equals 4 plus 4/3 x minus 3. And the other asymptote is y equals 4 minus 4/3 x minus 3. So let's put those 2 in our graph. We've graphed it on Desmos. So let's add the asymptotes to that. Let's see. Oh, we can add the hyperbola also because we wrote the equation for the hyperbola. X minus 3 squared divided by 9. That was one part of it. Look, that's an x squared, so it made a parabola. Minus, but we're about to change it all. The y minus 4 squared divided by 16 all equals 1. There it is. There's our hyperbola. Notice it goes right through the vertices as it needed to, right? It should have went through the vertices. There's the focal points. There's the center. All right, so that looks good. So now let's add our 2 asymptotes that we have the equation for. Y equals 4 plus 4/3 x minus 3. Oh, that looks good. It goes through the center. That's one of the requirements. It has to go through the center. It goes through the corners of that rectangle if we were drawing that rectangle on here. All right, let's do the other asymptote while here. Y equals 4 minus 4/3 x minus 3. And there's the other asymptotes. Now we can zoom out on this and show that the hyperbola gets really, really close, but never touches it. See how they kind of blend together at some point? If we zoom in, let's zoom in way up here. We'll see it is not touching that line. Closer we get, there'll start to be some separation. Oh, there it is. There's some separation. Look, it's not touching the asymptote. It's just getting closer and closer and closer and closer. So as we zoom out, it looks really like it's going to be the same line, but it's not. So there is our hyperbola with the asymptotes. All right, and there's how we did all of that. So it's good to know all of that, how to find A, B, and C, how to find the center, how to write the equation, how to write the equation of the asymptotes. So having all of this in your notes should be able to accomplish that. And you should also have in your notes, I didn't put it up at the top, but this would be in there. And I would put this in there because you need to know how to find A and B. So if you have this in your notes and this in your notes and this in your notes, that helps you get A, B, and C. You know the center is right in the middle between the focus points, or right in the middle between the vertices. So lots of great notes there for your hyperbola. All right, and these notes are also in the lesson. If you weren't writing them down now, let's go back here. All right, so this wants you to find the coordinates for the foci and vertices. And it gave you a parabola right here. But it gave you in not the standard form of a hyperbola, it's a standard form of an equation here. I mean, this is in proper form. So let's do this one, because this would be good practice for us, because you may have something like this on the test. And this goes back to that completing the square thing. Like, oh man, yeah, that was confusing. Well, the more you do it, the less confusing it is. So let's do this one. We're going to find the equations of its asymptotes and the foci and the vertices. All right, so I wrote the problem down. So we need to rearrange a few things. If we're going to complete the square, first let's move the 4 over to the other side. Okay, and let's factor out 16 for this over here. So let's do 16 y squared minus 2y. And then this is minus x squared plus 4x. And then we added 4 to both sides to move that over and equal 4. So we just rewritten it. We moved the 4 over, and then we factored out a 16 just to make that a little easier to deal with. So I'm going to go ahead and move this parentheses, give me some space inside of it. All right. And let's complete the square. Let's make this a perfect square trinomial. Let's make this a perfect square trinomial. We do that by taking that middle term, that -2, and dividing it in half. So it's -1. And then we square that. So we add 1. We have to add 1 to both sides, right? Or else we've changed the equation. Add 1 on both sides. So now we know this is a perfect square trinomial that would be y minus 1 squared. And there's still a 16 up there. Oh, we didn't add 1 because everything inside here is being multiplied by 16. We added 16 to this side. So we're going to add 16 to the other side, or they're not equal anymore. We added 16 because we put it inside the parentheses, and everything inside the parentheses is being multiplied by 16. So if we add anything inside there to balance it, we have to add 16 over here. Okay, minus, let's see, minus x squared plus 4x. So we can rewrite that as minus x squared minus 4x equals 20. We're going to factor out a -1. All right, factor out a -1. So now we got a positive x squared in here. Factored out a -1. Let's complete the square. Minus 4 divided by 2 equals -2. So that means this is going to be an x minus 2 squared. If we square that, it's 4. So we're going to add a 4. I'm going to add a 4 to the other side, but it's being multiplied by a negative. So we're going to subtract 4 from the other side because it's in the parentheses. So this is minus, and this is a 16y minus 1 squared. And it equals 16. Now, the last thing we need to do, because we don't have a proper equation yet, is we need to divide this to where this equals 1. Remember, our equations for a hyperbola always equal 1. So whatever's over here has to be divided by 16. This divided by 16, this divided by 16. Everything has to be divided by 16, both sides. Well, this cancels each other out. So this is actually y minus 1 squared minus. Now, we can put it over 1 just so we remember that our a equals 1. All right, put this over a 1. This is just what it shows. X minus 2 squared over 16 and equals 1. Okay, now we have the equation of a hyperbola. And it wants us to find the foci, the vertices, and the asymptotes. So the vertices, let's see. We need to know A and B and C. Well, I don't know if we need to know B, but we need to know B to find C. A is 1, right? Because this is 1 squared. 1 squared is 1. This is B squared. This is A squared, which is 1, because 1 squared is 1. This is B squared, it's 16, so B is 4. Right? So A squared plus B squared equals C squared. So this is 1 plus 16 equals C squared. So C is the square root of 17. I don't know if we'll need that or not, but yeah, we will need that because we got to find the foci. So to find the vertices, we start with the center. What's the center for this one? All right. That's the center. Is this horizontal or is this vertical? Well, the y is over here. The x is being subtracted. So this, if we look back at our notes, is a vertical. It's a vertical. So it's an up and down. So if we graph this, it would look like this. Oh, I'm sorry. It would not look like that. The transverse axis would be vertical. Oh, yeah, no, that's right. It would be like that because the transverse axis is between them. Right? So our hyperbola would look like that because the transverse axis is a vertical axis. It's an up and down. So that means the center is right there at 1, 2. The vertex is going to be above and below it. So we're going to add it to the y. So the vertices, one vertices is going to be at 1, 2 plus whatever A is. Remember, A is the distance between, it's 1, 2 plus 1. The distance between the center and a vertex. And there's also 1 below it. So the other one's at 1, 2 minus 1. So we got 1 vertices at 1, 3 and 1 at 1, 1. That is one vertice is another vertice. Focal points. How far are the focal points away? C. Remember the distance from the center to the focal points is C, which is the square root of 17. So one focus point is at 1, 2 plus the square root of 17. And the other is at 1, 2 minus the square root of 17. That would be the focus point up here. We would add the square root of 17 to the center. That's the distance between the center and that. Square root of 17. And this is how we would write it. We would not find the decimal rounded number that is the square root of 17 because that would be a rounded number. It would not be accurate. This is actually the answer for the focal points. Vertices. The other thing it asked was to find the asymptotes. So we're going to go back and see what's the formula. K plus A over B, X minus H. So one asymptote is at K. See, the center was 2. So 2 plus or minus. And we said it's A over B. So since I'm writing them separately, let's do plus first. A is 1, B is 4. 1/4 X minus H. The other asymptote is Y equals 2 minus 1/4 X minus H. All right, so there's all the answers for what it asked for. It asked for the focus points, it asked for the vertices, and it asked for the asymptotes. We have all the answers. Let's check and see if we got what they got. Check your answers. All right, here's where they started with the equation like we did. They completed the square. Did the same thing we did. They moved the 4 over. They factored out the 16. Then they added 1, which caused them to add 16 times 1 over here. They factored that. They made the minus, added 4, added a negative 4 over there because they've got that negative factored out. And they had the 16, so they had to divide both sides by 16. Same equation we got. Y minus 1 squared over 1 minus x minus 2 squared over 16 equals 1. So figure out the centers at 2, 1. Oh, we got that backwards. That was a mistake. I messed it up. I'm used to x minus h being over here. This is backwards. It's 2, 1. So these are backwards. So our vertices should be at 2, 2, and 2, 0. Because we're adding to the 1. So these are wrong. It's here instead because we went the wrong direction. Got those backwards. So that means our focal points are going to be at 2, 1 plus the square root of 17 and 2, 1 minus the square root of 17. And these have the wrong h and k. That's swapped as well. See the k and h. Just need to switch places with that. Y equals 1 plus 1/4 x minus 2 x minus h. See, I did that backwards. 1 minus 1/4 x minus 2. Okay. Woo. And simple mistake to make, and I made it. HK. This is K. This is H. Got those backwards. That's why we check our work to see what we did. So the vertices are at 2, 0 and 2, 2, which we have with our corrected numbers. So 2, 1 minus the square root of 17 and 2, 1 plus the square root of 17. And then 1 plus or minus 1/4 x minus 2. All right. We got it the second time. We had to correct it. H and K. Pay attention. Don't do what I did. H and K. Simple mistake though. If this was something where you had to show all the work, you would probably get 9 out of 10 if you made the mistake I did, because you did all the work correctly. I could see that you were doing things right. You just swapped H and K like I did. You'd probably get 9 out of 10 points if you showed all your work. If you just gave me the answers, I can't give you points because I don't know why you're wrong. I can't see that you switched the H and K. All I can see is you got the wrong answer. That's why show your work is so much better for you, because I can give you partial credit when I can see, oh, you knew what you were doing. You knew absolutely what you're doing. You just made the mistake of switching H and K. All right, so here's that summary table like they gave us before. If you have a hyperbola that has a center at H and K, if it's parallel to the x-axis, which makes it horizontal, you add C, add and subtract C to the H to get the focal points, add and subtract A to get the vertices. There's the equation. There's the equation for the asymptotes. If it's parallel to the Y, which means it's vertical, you're adding these numbers to the K instead. And there's the equations. Oh, here's a good one. If you have one of these equations, it looks like this, right? You got the ax squared plus cy squared plus dx plus ey plus f. You're like, you look at that and it wants to know, and you're trying to figure out what kind of equation this is. Am I writing an ellipse? Am I writing a I have no idea what this is, because it's like this. Well, you can start working it and dividing, getting equal to 1, all that kind of stuff. Or here is a nice shortcut, this table right here. This will tell you, is this a circle, parabola, ellipse, or hyperbola? Oh, how do you know? All you have to look at is what is A and what is C. Look, A is the coefficient of the x squared term. C is the coefficient of the y squared term. That's all you have to look at is the x squared and the y squared and see what their coefficients are. If those numbers are the same, a equals c, then this is the equation of a circle. If you multiply a and c together and they equal 0, which the only way that could happen is if one of them equals 0, which means one of them's missing. If there's no y squared in the equation, that means the coefficient for y squared is 0, which means this is a parabola. If there is an a and a c and you multiply them together and it's a positive number, it's a positive number. They're both negative or they're both positive. You got a positive number. This is an ellipse. If you multiply them together and it's a negative number, it's a hyperbola. All right, so I'm going to open up the chat. I'm going to look at the chat right here. We're going to classify these three. This is a good chance for you to get a little practice here. Look at that. It's a good chance for me to know who's still in class or who walked away and left me. Who's present. Let's look at this first equation. A, 25y squared minus 4x squared minus 100 equals 0. Okay, this all equals 0. Is this a circle, a parabola, an ellipse, or a hyperbola? Let me ask this question first for the chat. What is, all we have to look at is a and c. What is a in this first equation? What is a? Remember, a is the coefficient of the x squared term. I see a couple of answers. I see 3 answers, and they're all very, very close. None of them are exactly right, but they're all very, very close. Because it looks right. You're thinking, oh, the coefficient's 4 for x squared. Not exactly. There you go, Laura. Laura's got it. It's a negative 4. We have to count that negative in there because this is saying you're adding everything together. So if it's adding everything together and you see a minus, the coefficient must be a negative. We're adding a negative 4. Negative 4 is our A. Okay, what is C? For our equation A, what is the value for C? Now y'all are scared to put something out there. It's not a trick question. You got this. Looking up at our answer key up here, C is the coefficient of the y squared term. Doesn't matter where it is in the equation. Y squared happens to be listed before x squared, but it's there. Yeah, it's a 25. You're all right. All right, so if we multiply A times C, what is it? Is this a parabola, a circle, ellipse, or a hyperbola? If we multiply those together, are they the same? Is A equal to C? Do they multiply together to be 0? Are they greater than 0 or less than 0? If you multiply those two numbers together, that'll tell you, is it a circle, a parabola, an ellipse, or a hyperbola? Take a guess. All right, I'm seeing people saying hyperbola, which means if we multiply A times C, it must be less than 0. It must be a negative number. Well, we said that A was negative 4 and C was 25. And we know if we multiply a negative number times a positive number, it's going to be a negative number. Yeah, it's negative 100, which is definitely less than 0. This is a hyperbola. So you know when you're writing your equation, you need to get this to look like a hyperbola. It would be a minus. And in this case, since it's y squared minus x squared, that means this is a vertical hyperbola. All right, good job, guys. Let's try B. It's a little longer. 9x squared plus 4y squared plus 18x minus 8y minus 23. What is the A? What is the C? Multiply them together and just give me the final answer. Is it a circle, a parabola, ellipse, or a hyperbola? 9x squared plus 4y squared plus yada, 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 because we don't care about anything else. Because all we have to care about is the x squared and the y squared. That is going to determine everything about the shape of the graph. Laura said, I think it's an ellipse. Anyone going to back her up? Laura says, I think A times C is greater than 0. Looks to be to me, unless I'm seeing something wrong, which would make it an ellipse. Mackenzie agrees with you. Yeah, A is a 9. C is a 4. They're both positive. It really doesn't matter what they multiply together to be, because you know two positive numbers are going to be greater than 0. Yeah, I mean, we know 9 times 4. That's a pretty easy one. 36. But that's greater than 0. So yes, this is an ellipse. Good job. All right. This one gets a little trickier because there's 2 equal signs in it. Like, what in the world? That's okay. That's saying that 3x squared plus 8x is equal to 12y minus 16, which is equal to 0. So all of those equations equal 0. It means y must be 1.3333 repeating. It must be 4/3. But what is that? Is this the equation of a circle, a parabola, an ellipse, or a hyperbola? Oh, Laura's quick on this one. She says parabola. She's quick. Says, I've got it. She said, if I multiply A times C, it equals nothing. 0, zip, zilch, nada. Anyone else see that? What is A? Well, we see 3x squared right there in the equation, so we know A must be 3. All right, A must be 3. And C, let's see, CY squared. Where's the y squared? Wow, if there's no y squared, it must have a coefficient of 0. There are 0 y squareds in that equation. So 3 times 0 equals 0. 3 times 0. So this is a parabola. Good job. Just got to check your answers thing there. If you're working that, want to go back and try that. Hyperbola, ellipse, parabola. Good job. 3 times 0. All right. That's all of this lesson. Let's look at our 2 assignments. All right. So this first one, you find the vertices and foci. Gave you the equation. What are the vertices and the foci? Here's another one. Gave you the equation. What are the vertices and foci? This one gives you the equation, and you pick which graph it has to be. It has to be one of those 4. See, this one's a horizontal. See, this one's a vertical with a center over here somewhere. This one's a vertical that has a center on the origin. Horizontal with the center on the origin. Horizontal with the center over here. So where should it be? Which way should it be? All you have to look is the center and whether it's supposed to be horizontal or vertical. Let's see. Find an equation in standard form if the vertices are 0, 9, and 0, -9, and the focal points are 0, 11, and 0, -11. Which one of those would it have to be? And then finally, here's one of those show your works on there. Find the equation that has vertices that are right here and give you the asymptote equation. There's the asymptote equation. So use that asymptote equation to figure out what's the center and use all this information to figure out what's A and B. So you can write the equation. You definitely want to show your work if you're not sure if you're right. All right, let's look at the other assignment we have. This was the fun one. We're going to harken back to our grade school days and make a collage. All right, here is the actual assignment. Find at least 3 examples of conic sections in the real world. We're talking about marketing, so it could be in advertisements, architecture, it could be in buildings that you see, could be just found in nature, etc. It could be anything that's found in our world. So make sure your collage demonstrates at least 2 of the categories. So you can't do 3 circles. Well, you can, but then you need to do 4 things because you have to have at least 2 different types. You can use circles, ellipses, parabolas, or hyperbolas. So all you're going to do is look on the internet, and you're going to copy the pictures and paste them in a Google Doc. Just put them in a document. You can get a magazine, cut them out, and put them on paper, print pictures, and then take a picture of it if you want to. Just like we did back in grade school, we had a little magazine, and we cut out the pictures, make a collage, glue it on poster paper. You know, you can, if you really want to go old school, go right ahead. But remember, you have to have circles, ellipses, parabolas, hyperbolas. You have to have at least 3. You can do more. And you have to have at least 2 of the different categories. At least 2 of those categories. All right, you can do scanned images. You can do it on PowerPoint if you want, word processing, however you want to do it. All right, and then you're going to write a brief description about one of the conics. This Ferris wheel is a circle. Or this is the London Eye, which is a Ferris wheel, a big Ferris wheel. And you know, then you're going to write the equation that represents your conic, whichever one you chose to write about, whatever you're telling me it is. This is the London Eye. The London Eye is a circle, and then you're going to write the equation. Now here's something about it. Let me emphasize this point. Okay, I chose the London Eye. I took a picture of the London Eye off the internet. I pasted my Google Doc. It's really big. I rode the London Eye. It takes like half an hour or an hour to go all the way around, I think, because it moves really slow. But it's huge. I mean, it's like the biggest elevator you ever see. You get inside, and there's room for like 50 people in one car. You can walk around in it. You don't sit down. But let's say that's the one you chose, and you put it on your collage. Here's the London Eye. And you say, this is a circle, and the equation for the London Eye is x squared plus y squared equals 1. And I'm like, no. Well, see, you can assume, you can certainly assume that the center of your circle is on the origin, so you don't have to do an H and a K. But x squared plus y squared equals 1. Are you saying the radius of the London Eye is 1? 1 foot? 1 meter? It's not 1. It's a lot bigger than that. So you need to get some dimensions. You need to know the radius, or if you can't find the information, you chose just some random Ferris wheel somewhere that doesn't tell you, make an estimate. How big is an average Ferris wheel? You could Google that, right? So don't have a radius of 1, because I guarantee you that's wrong, right? Do something realistic. Okay, I'm going to say that this is 100 feet tall, so the radius is 50. So x squared plus y squared equals 50 squared, or 2,500. That would make sense. 1 would not make sense. So the other thing you include on this, so your 3 pictures, you're going to write about one of them. You're going to give the equation for one. So to do this, either find the measurements to create the equation or guess. So here's what you have to include. Your pictures, your collage, the description about one of them, the standard form equation of that one of them, an explanation of how the equation was found. I went to the website for the London Eye, and I found out that the height is this, and the radius is half of the height. Just tell me how you got the radius. Or I could not find the radius, so I estimated it to be this big. That's fine. Just tell me how I got it. It says 100 words with complete sentences, appropriate grammar and spelling. I'm not real big on counting words. If you have the information that you should have, I don't care how many words it is. Now, here's the other thing. Provide the source. I found the radius for the London line was this. Here's where I found the information. Give me the web page. Is it the London Eye's webpage? Did you find it on Wikipedia? Where did you find it? You know, make sure you just provide the source for any information that you're grabbing. And then I have a rubric that I graded on, put it on a doc and submit it. Now here's where you submit it, right? You go here. If you have it on Google Doc, share the Google Doc with me and just paste the link here. You can just put the link. I know that it's not letting us attach Google files. It's not letting us do that. But you can hit the share button, copy the link, and put it right here. So make sure to share it with me so that I have access to it. I'll email you. But yeah, just put the link here, submit my work. All right. There it is, the collage. It's not a big deal. A lot of people skip the collage, and I'm like 2 or 3 weeks later, it's like, hey, you never turned in the collage. Oh, yeah, there's a lot of work. It's not a lot of work. 3 pictures. Tell me which picture that you chose. Tell me what conic it represents, and then give me the equation for it. That's really all you're doing. The only thing you really have to work for is to find out how big it is. Right? What is the radius if it's a circle or an ellipse or something? You may have to find out the height or something to be able to write an equation. Depending on which one you choose, right? Probably you need to know different information. You may have to find an XY point like we did on some of those random problems. If the width of this parabola is this, then half of it, if I had it on an XY coordinate, the point 50, comma, negative 50 would be on there. I can write an equation with that. Whatever. It's math. You can do this. There's plenty of examples that we've done in the last 2 weeks, last week and this week. So, all right, guys. That's all we got for this time. Next week is the test. We're not going to spend long on conics. We did last week, this week, and then we're going to test it next week. So get stuff done, get things turned in if you're behind, and we will see you next week. Friday is an A-day, so I'll be here Thursday if your grade's below 70, or if you have questions. Maybe you need help writing your equation for your collage. Come on by. I'll be here Thursday. See ya.